boys and girls, today's lesson is going to be about symmetry. And basically it's TEK number 4.6. Your statement of learning will be, you will be able to identify and draw one or more lines of symmetry if they exist, and also to look at a two-dimensional figure to see that. So what are you going to be able to do today? You're going to learn how to identify a line of symmetry, and you're going to also learn how to draw one or more lines of symmetry. And how are you going to show us that you know how to do that? Well, by correctly identifying, is this a line of symmetry? And also to be able to correctly draw one or more lines of symmetry. So your lesson today is about symmetry. And if you look at this picture right now, you can see symmetry is all about, what does it look like? Is it a mirror image? Is it the same on one side as the other? And if you cut the object in half, is it going to be the same? So let's look and see. We have a circle here, we have our star, we have our square, we have our heart, and then we have a trapezoid. Okay, what is symmetry? Symmetry is the quality of being made up of exactly the similar parts facing each other. Okay, so a line of symmetry is exactly what it is. It is a line that cuts through exactly the center of an object. And it could be a picture, it could be a symbol, it could be a letter of the alphabet. This triangle is symmetrical, and that's the word that we use. This triangle is symmetrical because it has two or more equal parts that can be divided by a line of symmetry. So this is called the line of symmetry right here. And you notice this side looks exactly the same as the other side. And that's why this figure is considered symmetrical. Let's move on. Okay, it's an imaginary line. Okay, so the line of symmetry, the imaginary line where you could fold the image and have both halves match correctly. Now, some shapes have more than one line of symmetry. It all depends on how many times the object can be broken up into equal parts. If we look at this object right here, we can see that it has a line of symmetry that's going vertical from top to bottom. So this side matches this side. And it has a second line of symmetry that cuts right between the middle of it. It goes horizontal, and the bottom matches the top if we fold them side to side or top to bottom. So this object right here has two lines of symmetry. How do we determine if a shape is symmetrical? You can find if a shape has a line of symmetry by folding it. When the folder parts fit perfectly on top, all edges match, then it is a line of symmetry. Now, I don't know if any of you have ever made hearts where you take a piece of construction paper and you fold it together and then you cut from the folded line around. Well, of course, when you open it up, this side is going to match this side, which means that line right down the middle is the line of symmetry. So if you've ever made folded hearts, you've already started looking at things that have to do with symmetry. Okay, am I symmetrical? Let's look at this one. Now, look at this object right here. Is there any way that I can draw a line or fold it in order to make it symmetrical? Well, if you thought about making a horizontal line right across here, would the top match the bottom? No, it wouldn't. But what about if I drew a line right through the middle and I did it vertical and I folded this side to that side? Well, let's see if it'll show me. It may not. Yes, you can draw a line of symmetry on that object. So that object had what we would call a line of symmetry. Let's go on. Okay, let's look at this one. Now, to me, that looks like it's a square. Maybe it's a rectangle. It's hard to tell. But I do know that we probably have two lines of symmetry. Can you see them? It looks like if we went right down the middle there, that this side folded to this side would match, right? It also looks like if we did a horizontal line, my line is a little bit off, that we could fold the top to the bottom. So it looks like it has two lines of symmetry. Now, depending on if it's a square or a rectangle, it could possibly have more. Yes, it has symmetry and we drew the lines. Let's go on. Okay, is this object symmetrical? Now let's look at it. Is there anywhere on this object that I could draw a line and basically cut it in half? Well, if I drew one from top to bottom, this side would not match that side. And if I drew one across here, this side would not match this side. So I'm thinking that that one is not a symmetrical object. What do you think? No, it's not. We were right. Okay, ooh. Now, this is the letter L. This is what I look at. It's the letter L. Let's see if we can make this symmetrical. Well, I know I can't draw a line from top to bottom, a vertical line, and make it symmetrical. And I know I can't draw a line that's horizontal that makes it symmetrical. Now, the only other thing that I could think of is if I drew a line right here. But I still don't think if I did that, that it would be symmetrical. So let's see. Nope, we were right. It's not symmetrical. Okay, so now there are several different types of triangles, guys, and they can be symmetrical and they can have one, two, or more lines of symmetry. Okay, the first one we're going to look at is an equilateral triangle, and that word equilateral says something special. It means all three of those sides are equal. They're the same length. So you could rotate this triangle and you could have a line of symmetry here. You could have a line of symmetry there. Or you could have a line of symmetry there. Now, a line means it goes all the way through. I want to make sure you understand that. It's not just to each point, so you don't have 6 lines of symmetry here. The line goes all the way through the object, and that's a line. So here's 1 line, 2 lines, and 3 lines. So an equilateral triangle has 3 lines of symmetry. Now this is an isosceles triangle, and the way how we know it's an isosceles is 2 of the sides are equal. And since it is an isosceles triangle and 2 of the sides are equal, we will have 1 line of symmetry because the 2 sides are equal and 2 angles are equal. Okay, and the last one is a scalene triangle. Okay, and that was the one that we just looked at earlier. There are no lines of symmetry because there's nowhere that I could cut this because none of the sides are the same length. So there's nowhere I can cut this in order to make a line of symmetry. Now, let's look at quadrilaterals. Ooh, what makes a quadrilateral? Well, we know it has to be a polygon, and we know it has to have 4 angles, and it has 4 sides, and that's what makes a quadrilateral. All right, of course, we know a square. A square has 4 equal sides. They're congruent, and they have 4 right angles. Well, when we look at a square, we have 1 line of symmetry that goes from top to bottom. We have the second line of symmetry that cuts through the middle, horizontal. And then we have a line of symmetry that goes diagonally. So actually a square has 4 lines of symmetry. Okay, here's a rectangle. When we look at a rectangle, it's a lot like a square, remember? So it'll have a line of symmetry because it has 2 equal sides, opposite sides are equal, and it has 4 right angles. So we have a line of symmetry going vertically, we have a line of symmetry going horizontally. But because these sides are not equal, we are not going to have lines of symmetry that go diagonally. And then in a regular quadrilateral, it is still a four-sided shape, but it does not have any equal sides. So no opposite sides are the same length. Therefore, we cannot have any lines of symmetry. Okay, we have two more shapes that I want to talk to you about. You all are familiar with the kite. Okay, it is again a quadrilateral. It's a four-sided shape. Okay, and it looks like it has two acute and two obtuse angles, or it looks like, nope, it looks like it might have three acute and possibly one obtuse. But the line of symmetry goes right down the middle, and it is a vertical line of symmetry. And then you have the rhombus. I call the rhombus again a lazy square. Okay, all the sides are the same length, but it is, instead of looking like a square, it's smooshed. Say the word smooshed. Okay, and in that case, because all the sides are equal length, it's going to have at least two lines of symmetry. It's going to have a vertical one, and it's going to have a horizontal one. Of course, it's not going to have any diagonal ones because basically we're hitting the diagonal the way it is. Okay, let's go on. All right, regular polygons. What's a polygon? A polygon is a figure, a closed figure with straight sides. So closed means that all the lines are touching and connecting and making angles. A circle is not a polygon. Okay, so all regular polygons have equal sides and all angles are equal. All right, here's an equilateral triangle. We just talked about one. All three sides are equal, so it has three lines of symmetry. A square, all four sides are equal, and it has four lines of symmetry. Ooh, a regular pentagon. Now, a pentagon can be a five-sided shape because penta means five. A regular pentagon, actually all the sides are equal length. And because all the sides are equal length, it has five lines of symmetry. A regular hexagon, let's see if I can get this to pull up. Okay, a regular hexagon, which means all sides are equal, because you can have a six-sided figure that the sides are not equal, and that is, it still would be considered a hexagon. So a hexagon, a regular hexagon, will have six sides of symmetry, top to bottom, across horizontally, and then through each one of the sides. And remember, the symmetry is all the way through. A regular heptagon, seven-sided figure, is going to have seven lines of symmetry. And a regular octagon, an eight-sided figure, will have 8 lines of symmetry. So just remember that, however many sides that they have, and if they're all equal and they're the regular one, then they're going to have that many lines of symmetry. But only if the sides are equal. Okay, this is the one that I think is so cool, is your circle. And this one's a little bit off. It looks like an oval, but picture it as a circle. A circle will have an infinitive amount of lines of symmetry. It just keeps going on and on and on all the way around, because you just keep moving over little degrees as you're moving over in degrees, because remember, a circle has 360 degrees. So even if you drew a line of symmetry on each one of the degrees, you would have 360 lines of symmetry. However, you can just make little bitty movements, and that's why they say that on a circle, the lines of symmetry are an infinite amount. Okay, guys, that's all for the notes today on Smartboard. So remember, this lesson is about identifying lines of symmetry in an object, and also being able to draw lines of symmetry in an object. And I talked about it just a second ago. It's not only shapes, but it can be pictures. You could have a picture that had this. Well, if they were more alike. And you would see the line of symmetry could be there, or the line of symmetry could be there if it was equal. You could have letters of the alphabet. Now, if that was equal, imagine that. And your line of symmetry could go through the letter of the alphabet. So, start looking at objects and thinking about, do they have any lines of symmetry? Most of the time, look at the first vertical and then horizontal. And then from there, you can look and see if they have a vertical and they have a horizontal, maybe they have a diagonal. So your lesson today is all about symmetry and recognizing symmetry in shapes. I'll see you later. Bye.